Hello everyone. If you are a data scientist, AI engineer, or machine learning engineer, or just the machine learning practitioner, the understanding machine learning lifecycle is very important for you. Depending on who you talk, you are going to get a quite different explanation about machine learning lifecycle. However, some of the component and the stages are going to be the common among most of these explanations. If we look into machine learning lifecycle stages, we see only these four stages, where first one is the data preparation, second one is the training and the tuning, and the third one is the model deployment and monitoring, and then the last one is the inference. So this tutorial is designed to go more deep into all of these four stages and learn deep, detailed, and the technical overview of machine learning lifecycle. Hello everyone, my name is Avkash, and in this video I will take you inside the each functional stage of machine learning lifecycle and give you a detailed overview about most of the components in each of these stages and how they work together. I'm super excited to share this information with you. So let's get started. This tutorial is motivated from this article from Amazon AWS. This article was focused mainly on Amazon AWS machine learning services and the architecture of a machine learning pipeline created using Amazon SageMaker. I like the image I like the whole detailed machine learning lifecycle view created by the author. So I have used the image to create the content for this article. So the full credit goes to the content creator who created this image, and that gave me motivation to create my own tutorial around it. So I appreciate their help. Now let's come back to our tutorial. The data wrangling is another part of data preparation. The data wrangling steps could be defined such as cleaning your data, finding empty values in your data, and perform the imputation depending on various logic which apply to your data or the business domain. The normalizing your data can also be part of data wrangling, transforming and encoding data. So could be various different things you could do in the data wrangling steps, and it's all depend on who you ask. But in general, the idea behind the data wrangling is that you are working with the data and performing several different kinds of operations. And depending on how big your tool chest is, how many ways you could wrangle with the data, the number of steps you could apply in that data wrangling phase of your data preparation. One important thing in data preparation is called the unbiased, removing the biases from data. So very first thing, you need to know if your data is biased or not. And in order to get that information, you need to have some kind of detection methods. And you could have domain expertise where you could find it, or there could be domain specific or business specific tools can also be applied to find the bias if available in data. And these days, in last few years, the fairness in AI initiative is very popular. The organizations are trying to make sure that data is unbiased when it is made ready for machine learning, so the model can be created which are not biased. They do not sway one way or another towards certain signals in the given data. So detecting the bias in your data and mitigating it is all parts of creating unbiased data, which is required for fairness in AI. And this also applied for your business problem, because if your data has bias in it, it is definitely possible that your model will also going to have that property. So you have to make sure that your data is ready and it's unbiased. At the last step, when you are performing these various data wrangling methods in your data preparation step, your final and the ultimate objective is to generate the ML ready data. Means this data is machine learning ready. It means if we try to build the machine learning model, it is highly possible that the model will be with higher quality and it can be used for the specific machine learning problem we are trying to solve here. So once you believe that your data could be machine learning ready, the next step is the feature engineering your data. So feature engineering itself is a very large topic. You could use the automated tools which are available to extract the feature, and depending on your domain knowledge related with this business problem you are solving using machine learning and the number of tools or experience you have, you can make this feature engineering process could be very small or could be very large. But in a sense, feature engineering is that adding more and more meaningful signals in your data so that you could build a machine learning model which can be generalized enough to solve your current business problem with varied wide variety of incoming data. Data labeling is another step, and depending on what kind of business problem you are trying to solve, one way or another, it is needed that you might need to label your data. For example, if you are working on unstructured data, you have to add the proper labels related with your data. After you complete the feature engineering, means you created massive amount of new features based on your given data, you really need to check whether these features are important enough that they could actually give meaningful results while building your model, or they could be just dead weight hanging in there. So the feature importance is very important when we are working on pre-training. There is a feature importance part which also come in the model validation parts, which we are not talking here right now, like the post-training. But pre-training, the feature importance is basically understanding the value of the feature while that feature will be used in the machine learning training process. So depending on a feature which we have just created in feature engineering, we need to make sure if that feature has high importance, means it's going to contribute significantly in the machine learning process, you keep it. Otherwise, before you are feeding your data to machine learning training engine, you can hide it or you can remove it. While in this phase, you are also going to transform your data, and the transformation could be done at, again, data type. Because sometimes when you are using unstructured data, the transformation steps could be different. While you are using a structured, highly correlated data, these transformation steps could be very different again. So transformations will be applied in your data to make your data even more meaningful for your machine learning process. So these transformations you are doing because you are trying to make your data more meaningful, more machine learning ready. If your data has lots of labels and you are not adding the specific signals related with those labels, your data will not be that much useful for machine learning. So using joining methods to bringing the more details related with your given label and coding all most of your features where it has to be done. All these steps are required for you so that you could make your data or you could prepare your data in a way that your machine learning training as well as the machine learning model could be more meaningful and useful for your problem. The new advances in machine learning in last few years, especially 2020 and 2021, is the emergence of feature store. So feature store itself again is a very big topic these days. There are several new organizations having feature stores. A very popular feature store, Feast, which is designed by the company or a startup named Tecton. Another organization named Hopswalk. They also have open source feature store. Besides that, if you look into the Databricks, they have feature store, and SageMaker and Amazon, so AWS SageMaker, they also have the feature store, and Google, they also have a feature store called Vertex. So feature store is itself very important aspect or very important component in machine learning pipeline. Feature stores are online and offline. I won't be talking a lot more about feature store because I do have another tutorial which talks about feature store itself and then using feature store in Feast. So please look into those tutorials to learn more about it. But at this point, these features which we have created in our aggregated data, they all can be stored in your feature store. And there could be automated code can be added. So when this data, which is aggregated and ready for feature engineering, these automated scripts or these automated processes can generate your feature and store the featured data in the feature store. It means that when you are trying to build your machine learning pipeline, at that time, the data will be read directly from the feature store. It means that all the new coming data will go through with an automated process, and all these new features will be generated and the values will be stored into the feature store. And that's the idea, is that whenever we try to build these feature stores, so these feature stores are used to send the data for your machine learning training and tuning stage. So when we talk about offline feature store, we are talking about the historical features. And reason historical term is really used because at this point we got the data which is coming out from various sources and then we are working on it. So for that reason, all that features which we have used on incoming data to enhance our data, they all are stored in feature stored and they can be used for the training. So these features could be sent directly to a machine learning training as input, and this offline data can also be considered as a historical data, and which is basically taken from the feature engineering, pre-processing or the post-processing. So the historical data is stored in feature store. However, the metadata related with all these features specific to your data, they all considered as the data artifacts. So this data artifact related information goes into the registry. And when we talk about feature store, there is a offline data store where these features are stored, but there is also the registry part. And that registry has the information about your data metadata. So pre-processing and post-processing, this whole pipeline generate the data artifacts, which can also be used depending on whether you are trying to use them during machine learning or even the subsequent part of your machine learning pipeline. At this point, we can assume that the data preparation stage of our machine learning life cycle is kind of completed or discussed in a way that it's almost ready, in a way that now the output of this stage can be fed into the machine learning training. And just please make sure that you have ability to just fed the feature engineering or the fully featured engineering data directly to your machine learning pipeline, or you could use the feature store where you are using the historical data as the features for your machine learning pipeline. So now We are in the machine learning training and tuning stage. At this point, we have the newer concepts such as ML pipeline, machine learning pipeline, which most of these organizations talk about. And the very first step in machine learning is the selection of algorithms. These algorithms could be selected based on your knowledge about machine learning overall, the understanding of your data. Depending on the type of data, certain algorithms will be better than other, may perform better. And that is all coming out from how much experience you have within the machine learning domain as well as the business domain where you are solving the problem using machine learning. The algorithm selection, basically you are trying to do the various experimentations, trials and errors and all their things really stack on one after another and gives you understanding of what you are doing. And now these days with the emergence of AutoML and majority of the machine learning platforms give you fully automated machine learning pipeline where your data is fed into a collection of algorithms and each algorithm provides some information. So some of these results and all of these results from all of these algorithms are combined together to generate the final result. So the algorithm selection could be fully automated or it could be generated by you or by the data scientist who is working on the problem. And it's all depend on a few lines of code versus a massive amount of code which is doing an auto ML process. Companies such as H2O.ai, Data Robot, SageMaker, everybody has these AutoML built into in their platform. At this point, we believe that your algorithm selection and all that machine learning training, all that process is being set. It means that now you can start performing the model training. Means the selection of algorithm, parameter, all that thing has been pretty much stable now, and then that step is ready to perform the machine learning training or model training. At this point, it is all about the compute or the environment which is going to take you further. And this training could be hosted, could be local, and it's all depend on the scope of your problem. People can do machine learning training in Jupyter Notebook with a very small Python environment. And for some organization, you need a very large distributed servers where you could perform this machine learning training, which takes thousands of computers for several hours to several days. So it's all depend on what kind of problem you are solving. And that's what your machine learning training part is going to take care. Finally, the metrics validation. Based on your validation, if you see that there needs to be improvement, you use the hyperparameter tuning. And now these days, even the hyperparameter tuning can be done through AutoML and through multiple cycles of tuning, then algorithm selection, then training, then keep doing this almost full time. You have ability to build these machine learning models after several iteration of hyperparameters tuning in automated fashion. At this time, we could say that the code artifact, which is related with your machine learning training selection, like algorithm selection and several other things, even the parameters and what their values was used and the range, etc. Your model artifact, all that things, and all that information can be stored into a component such as artifact lineage. Companies like AWS, they do have a lineage tracking tool in their machine learning pipeline, which actually tracks the data artifact, code artifact, model artifact, and artifacts means basically just a metadata, not the real data itself. But it's a metadata. It also has the some of other information within the metadata. So sometimes the value ranges could be available, the number of parameters are, and the applicability of parameters at what stage. So there could be a variety of information can be added at all levels. Data artifact related with your data, metadata, code artifact, which means the functional machine learning algorithm related information, and finally the model artifact. And that all can be stored into this artifact lineage. And as you are going to go with iterative feature engineering plus machine learning training process, you will have ability to track and see that how this data was changed or how this machine learning model was enhanced or if degraded, whatever happened during this training process, all that thing can be validated, can be tracked, and can be seen back in time to understand everything all around it. So red part, what you are seeing here is mostly the new age components which are being added into the machine learning pipeline in last 2-3 years of technology advancement. And this machine learning pipeline where we perform this machine learning training, the output of this process is the model, and some of the organizations, they actually have this model registry. It means once the model is created, you can export that model to the model registry. Very recently, I have created a new tutorial which related with using Comet ML machine learning monitoring or observability platform, where they have a full end-to-end tracking built into using their own proprietary platform, but is available anybody to use, where when you are performing your machine learning training, all that metadata related with your training and model and some of the data artifacts, they all can be stored into the machine learning experiment or machine learning tracking part of their monitoring platform. And that model can also be exported to the model registry. And depending on how many iterations of your machine learning training you performed, at each iteration, you can update your model registry with a new version of model. So while you are keep iterating your machine learning pipeline, you do have ability to save all of those models with their model artifacts, with all the metadata, which includes your hyperparameters, which also include the histograms and the algorithms and their parameters and the settings, etc. Could be anything, or in some cases it could be whole source code related with your training pipeline. That all can be added into model registry. So model registry is another new way to do machine learning. So as I mentioned, the Comet ML was one, and Neptune is another organization, and DeepChecks, which is open source project, which also doing good work. They have open source project. There are several new technologies are available in market where you could have these model registry used for your project, or you could store these different artifacts as well. At the third stage of machine learning life cycle, now we are in the deploy and monitoring stage. And the input of this stage is your model. Model can be sent directly from your machine learning pipeline. It means the model was created and it's been sent for the deployment, or this model can also be sent from model registry, or the deployment and monitoring process, or that whole component can pull the latest available model in the model registry and deploy that. So there could be several ways that model deployment can be done. However, at this stage, we could say that model testing is part of deployment, where a model is tested. Again, the model testing is a very important part where we are validating the model usage with very close to the real life problem. It means the new data where the model is not being trained to, or model has never seen, is being applied to get these results, and we validate those results based on the actual results we have, and the system generate the model accuracy score. When your accuracy is met based on your organizational need, then you believe that that model is ready to be used in your business setup or to solve that specific business problem. So model testing is a very important part. And once model testing is done, and then you believe that your model accuracy is up to where you want for this particular problem, then you deploy that model. And then model deployment could be done in varieties of ways, that you can make your model available through API. It means you just call that API whenever you would want to perform the inference or the scoring, and that API will process the model and that data will be sent. Model will use that data to perform the inference, generate the score, and the API result will be given back to you with the score of your input data. In the batch transform, you are basically hosting your model in an environment where, depending on your batch size need, it could be 10 records per minute, could be 10,000 records per minute, could be 1 million records per second. It's all depend on what business problem you are trying to solve. So for example, in anti-money laundering system where you are trying to validate a fraudulent transaction, and if you have a very large organization such as credit card transaction, you need a massive amount of a system where you could perform these real-time scoring for to validate whether a particular transaction is fraudulent or not. So depending on need, you will build these model deployment stages, and you are basically fulfilling your business requirement. Means your model is being used in the production. So at this stage, when you are here, technically it's the real result or real test of your model or real test of your business, where everything what you have done is being evaluated. And now these days, again, the advance in feature store. So new incoming data, which is being fed into or made available to feature store, is used for scoring or for the inference engine. So now you could ask why we are using the feature store online. And the big difference here is that if you remember, when this data was being fed into the data preparation system, and we went through with several data wrangling step and then feature engineering step, all those things were used to take your input data and enhance it in a way that it can be used for machine learning training. This new incoming data also needs to be transformed in a way so that it's almost identical to that the data which was used for machine learning training. It means that if you are not going to have the online feature store for the inference, you need another process where you could take that incoming data and perform the data wrangling and required feature engineering as needed. So having the online feature store, basically the incoming data is went through with same process which was used earlier, so that your data can be transformed in real time and can be sent for the inference or for the scoring. So this is the big reason the organizations are start using feature stores for offline, which is for historical data, and for online for the incoming new data, and mostly that data will be used for the scoring. Now we could say that the model inference and interpretability is a step which can be applied now. So depending on your business setup, the score you are getting from your model, you may need these requirement or these business requirement. One is a model interpretability. You want your model to explain, if the result is this, why that result is this. Means the explanation behind the model decision making process. So the model decision making process is no longer black box for you. It is very important for you to understand at this point, because certain businesses or certain verticals such as insurance, banking, or even the fraud detection, for example, if model is flagging a particular transaction as fraudulent, you really need to know what are the basis, what are the factors for a model is flagging a particular transaction fraudulent or otherwise. So model interpretability does require, and it is very important part. And then as more and more machine learning models will be used in actual businesses, in real world business problems, you do need model explainability and interpretability. So interpretation and explainability are two separate things. Sometimes they could be considered as one, but the idea here is that the model explainability is related with, if the model result was this, the reason behind those. The explainability is basically just tells that what is being used in order to bring that result. So combining model interpretability and explainability, your machine learning inference process is no longer the black box. It's more open approach where you could explain the machine learning model results to any person in very explainable terms. So that is another enhancement which has been added in machine learning life cycle in recent years. There are several new organizations who really work dedicated in machine learning interpretability and explainability part. Companies like Fiddler, companies like Rise, machine learning observability platform where they provide these functionality. So there are several new organizations which come into the Comet, ML, you could say Neptune. So there are several organizations or startups who are working hard in these. The existing machine learning platforms such as H2O.ai, Domino Data Lab, Data Robot, ML Flow from Databricks, Data IQ, all these platforms, they have machine learning interpretability and explainability components integrated in their machine learning pipeline. So whether you are using machine learning model in real life scenarios, or you are even doing the testing model and you are validating whether model is performant or not, you could use these explainability and interpretability features to give the confidence within the organization to use that model or not. Because if you are trying to use a model in real life business scenario, you must be confident enough that the results which are going to coming out from that model will be applicable to the business. So even the generating the confidence in a model, you do need model interpretability and explainability components in your machine learning pipeline. So that's what it is in deploying and monitoring. So that's why we kept this model inference, interpretability, and explainability in both stages, training as well as the deployment and monitoring. And they are applicable on both stages equally. One more time, in training stage to give you confidence so that you could use that model in your real life business scenario, and in the deployment and monitoring where the explanation to every results can be given for your business need. The last stage in our machine learning life cycle is the inference. And inference is really a very important part. It becomes more of a responsibility for the IT, because at that point, what you are trying to do is that you are making your machine learning a model available, whether through API or through the batch transformation, whatever it is, so that it can be used in real life business scenario. And the inference setup could be very small or could be very big. So for example, if you are trying to create anti-money laundering process, which we just talk about it, then your inference servers will be a collection of several servers. It's a forest basically, where you are trying to process these tens of thousands of hundreds of thousands, even million records at second level or even more. If you are trying to use machine learning models to provide these login capability to different kinds of systems such as banking or highly secure systems, and these machine learning models are used to give various weights for a particular person who is trying to log in into the system, that can also be very large. And depending on your need, sometimes you need to create these inference within few milliseconds or even the sub-second level, because your business requirement, you don't want somebody to wait, or waiting is not thought when you are performing inference. So inference itself could be a very vast, could be a very deep technical aspect of machine learning life cycle itself. However, it is more towards the IT or information technology, a DevOps part, rather than full machine learning or MLOps. However, it is very important part of overall machine learning life cycle, because everything what is happening there is going to be applied to your machine learning pipeline, and that's what we are seeing next. So the new data is coming, your machine learning model is applied, and now your machine learning model is generating those results. And those results will be fed into your business process, whatever is really needed for that particular business where this machine learning pipeline is created. The new data will be sent to online feature store, so that before sending the data to the inference, all that feature engineering and all that scripting, what the data transformation, everything has to be done, can be done in a way so that your data is ready for inference. Sometimes this new data which is being sent to feature store will also has to be saved and then converted into the historical data, because it is very much possible that when you are trying to retain your model, depending on your business need, you might need to use all the data. It means the data when your last time machine learning model was trained, and then the data which has been accumulated since the machine learning model been trained. It means you still have a lots of new data which arrived, and that machine learning model needs to learn these new signals in your new data. So combining all that data in a way so that in the retraining process of your machine learning model, you give all that data. And for that reason, the combination of these offline and online feature store, and then the ability of having these data lakes and master data management and variety of new capabilities are going to be very helpful. We have pretty much completed our deep and detailed overview of machine learning lifecycle. One thing I could say that it's all depend on person to person, because somebody who is having more experience, they might have even little more different view about this machine learning lifecycle. However, depending on how many people you ask and how many people will explain or interpret this whole life cycle, in majority of a way, most of these components will be common. So if you are finding one new component somewhere, and if you are not seeing one component which is being explained here, that's very common and it's totally applicable. So I hope that you have enjoyed this content which we covered in this video tutorial. That's all I had for you in this tutorial, and I will be excited to see you in my another tutorial. That's all, my friends. If you have enjoyed our content, please like it, share it, subscribe it. And finally, please remember, be good and do good. Thank you.